Hi everyone. I decided to do a comparison test for those that really don't know really what difference would be in a motor action. And to make the tests fair and all that, I decided to use my pulse circuit, which means it's just going to turn on and turn off the DC voltage at a specific frequency and amount of time. And I've just taken an off-the-shelf motor here, and I think that's a 24-volt motor, and I added a bit of a weight, a flywheel on it here. It's probably about 1/4 or at the very most 1/3 of the weight of my test device flywheel. But anyways, that's fair enough. I just wanted a bit of weight so that when we do increase the voltage we can see the behavior of the current. So what I've done is I've made the pulse exactly the same width and at the same frequency. So if you look at the data here, I had it on 250 microseconds there on my test where I had broken apart the test device at the 30 volt range. And this scale here is just set a little different because the voltages are not exactly the same and the current. But what I've done is I've just kept it so that it looks very much to the same size and form, and definitely it's the same width. So this motor is able to turn the rotor that weight at the same RPM. So 1130 RPM, and this is what it's using. So it's operating at 26 volts and basically 10 watts input, and there you go. So about half of what this guy did, and delivering the same RPM. And to my surprise, basically when you're pulsing a off-the-shelf DC motor like this, it behaves very much the same as what I was doing here. So I'm starting to conclude that there really wasn't anything special out of this, because I'll do the same kind of thing. I will now go up and down with the voltage and look at the action and tell me if you can, there you go, going up. Tell me if you see a difference. I thought the current would have just shot up much faster, but that's all it's doing, which is about the same as what the other my test device was doing. And if we look at the, we'll go back, check our RPM here. I'm going to put it under load as well. Okay, I think it'll just fall back at about 1130. It's around the 26 volt range. Now I'll give you a view of going up and down as well here with the voltage, and you can see the watts difference. So I don't know, to me it's starting to just look all the same, and I thought there would be a big difference. But anyways, I like to test my device and really know the truth and not kid myself about it. And now the next test would be to put it on load. So we got to go back to our I think it was 26 point somewhere around there. We should have about 1130 RPM there. Fair enough, it's climbing there slowly. So now what I'll do is I'll just put my finger on the flywheel here, and we'll just look and see what happens on the scope. So there's my finger on it. I've already dropped by that 130 RPM by now, and we don't see much difference on this as well. So again here, I would have thought this would have shot up, and it's not. When the motor is being pulsed, it's very different behavior. And here we're back at the meters, and I'll put the I'll let it find its says RPM there, so it's stabilized. So basically at about 10 watts it's there. So now I put my finger on it, drop the RPM, and it just takes about one more watt, and I believe this was doing about the same kind of thing. So I don't know, I don't really see the advantage. Maybe if this didn't change zero at all, I mean if the wattage didn't change, but when I did put it on load, it did require a little bit more power, but I thought that was basically because the pulse width would get larger, but maybe it is the counter EMF kicking in, and just you can't see it so much when you've got a pulse, and that's what I'm finding, the same thing with an off-the-shelf motor, pulsing that. And I'm also been collecting the flyback, because as you see there is a flyback there, and I'll reduce the voltage there and you'll be able to see it. I have it on a fine setting there for the voltage instead of large increments. I'll go back to larger increments there. So you saw the flyback spike now, and we're not collecting anywhere near the flyback that we had from the other one. We're at about 24 volts across our 1K ohm resistor. But mind you, we are only putting in 10 watts to this motor. So anyways, I thought I would report this, and unfortunately I can't claim that there really is an advantage with this device. And if Tin Man can do his test and confirm anything interesting, well, we'll see. That's it for now. Thanks. Bye.